Welcome and thanks for joining us. My guest today is Brandon Gulla, the Chief Technology Officer of Rancher Government Solutions. Brandon, good to have you with us.
Tom, thanks for having me.
And let's talk about edge and clouds and data centers. Those have emerged as the three kind of big infrastructure components for federal agencies trying to deploy digital services and improve performance. And so you've got these three areas. What is a good contemporary strategy architecture for incorporating all three of those elements? What does it look like as we go into 2022 and beyond?
Yeah, Tom, great question. You mentioned the three different infrastructure platforms that are really being targeted by today and tomorrow's federal industry. And while those are three bespoke infrastructure solutions, we need to focus on three pillars of excellence within those three different types of infrastructures. Commonly, we hear those as security, speed, and scale. And I think top of everyone's mind right now is certainly security. We heard late last week about a Log4j huge vulnerability that popped in JVM-based applications, something that is a very low-level, function within a computer software module that essentially could be exploited at any time. People don't even realize that they're using Log4j. A developer who just joined the team might have been on 3 months. This is something someone wrote and implemented months ago. They have no idea what that software footprint could actually be. So of course, security is number one. We need to be working with our supply chain enthusiasts and experts to ensure that we're having attestation as well as full transparency on what software modules are being baked into tomorrow's technology. We have to have that single source of truth in that chain of evidence to ensure that all of our dependencies and components of our software stack is not just secure today, but can be validated and audited in months and years to come. We all know that the federal government doesn't move as fast as other industries. We might have old software running weapon systems and things like that. We need to ensure that we have the correct state and versioning applied to all of these systems as they continue to grow.
So this is where the software bill of materials could really
absolutely
come is an important part here.
Absolutely. The bill of materials, that's something that's really coming a flare lately. We've noticed in the cloud industry and especially within the federal industry, mission adopters really focus on functionality first. Intelligence communities and very tactical customers, they care about the mission element and how a technology can impact mission. It's later in life and later in the life cycle of software that they start to check all the boxes and really focus on security. Unfortunately, we try to focus on security out of the gate, but we also know that federal industries are now catching up to how appropriately scan containers, how to monitor Kubernetes network systems. So now that they've caught up, they focus on compliance. And software bill of materials is a big part of that. We've seen a lot of change just recently in the Kubernetes community within the SigStore type of community of practice, focused on the signing of artifacts, the bill of materials, things like that. We've seen companies start to pop up. ChainGuard is one that has popped up recently that has focused on bill of materials and software signing. And that's focused primarily out of work that Google did. And they broke off and started ChainGuard. So I'm really excited to see the community start to focus on security more.
All right. And then speed and scale have to happen within that security framework. And that idea of containerization seems to also support speed and scale.
It can. Containerization is not, an elixir that you drink it and all of a sudden you're cloud native and you're secure, right? You can take a very insecure application, throw it in a Linux Docker container, and it's still just as insecure. But what it promotes is the idempotency and the immutability that software can provide, allowing you to move an application from infrastructure to infrastructure, maybe classification domain, to the tactical battlefield in a way that is flexible, and highly decoupled from the underlying infrastructure. And that's where the speed component can come in. When we think of speed as well, we're seeing a lot of advancements in not just connectivity when it comes to US East 1 and all these new data centers coming online, which I can talk about in a second. But we're seeing 5G, right? 5G is a buzzword. I don't want to beat it up, but what 5G does enable is the extension of the information domain. Where before you might have a sensor applied down at the tactical battlefield or at the quote edge, and it would be unable to process that data and send it back in an effective manner. Now with 5G, we're seeing that infrastructure domain extend out into the battlefield. Maybe a light pole, a wind turbine, sending back diagnostic information. We're seeing 5G open up a lot of doors, but with 5G, I don't want to focus too much on that, because with companies such as Starlink, from SpaceX and other types of companies focused on satellite communications, Intelsat as well, Kratos, they're opening up a huge domain that was once sensed as a dying world, right? Satellite was very latent, focused on 3G, LTE, 5G, but now we're seeing through the commoditization of space and the embracement of space in the weapons industry, a new advancement towards not just terrestrial-based communications, but opening the door to all mediums as well.
All right. So then you therefore have a choice of fast ways to bring in the edge computing facility, and you have a efficient way through containers to deploy them to the edge. So it sounds like now the edge itself can come back into the fold, in a sense, as a high performing part of your computing infrastructure, and not just for low bandwidth types of IoT devices.
Right. Yeah. IoT, everyone's refrigerator is running, some Linux distribution underneath the hood. I saw on Twitter people complaining that they couldn't do their laundry because US East 1 was down in Amazon a few weeks ago, right? We want to enable the future and not hinder it based on connectivity problems. So we've seen, a huge push into this market. But what's really important to focus on is also the security, because while you can start putting these devices at the edge, they could be exploited, or even, people tend to forget about physical tampering, right? So you need to have a way. You don't want a adversary or a competitor to come out and grab your Raspberry Pi that's in the field, or your single board computer that's in the field processing data. You don't want them to exploit that and become compromised. So there's a lot going on, both on the physical security realm as well as the TPM module approach, which we're here at Rancher Government Solutions. We're working with plenty of partners in the physical computing world to find that chain of trust from the hardware up. That way we can validate hashes and ensure that these single board computers and other edge technology that are deployed in the field have a chain of trust that are immutable and can have the integrity that our mission demands, both on the physical and digital side.
All right. And then the idea of scale, we haven't discussed that one quite as much, but as the federal government goes to these digital services, the next generation of digital services, and trying to increase the customer experience, another high priority right now for agencies pretty much across the government. How do you get scale in such a way that is also efficient and economical?
Yeah, scale is one of those things that I'll be honest with you. I think the first two S's in security and speed actually enable the scaling part. So we've all gotten used to over the past few years of having AWS, Azure, Google, Oracle, and IBM Cloud as being one of the elastic compute infrastructures. If I need a server, I can just go spin one up, right? So you have that ability to scale. But what we've seen is, while those are focused on the individual data centers, we're starting to see a scale from a geographic perspective. So as new data centers come online that are more tactically, geographically located closer to the battlefield, as well as seeing this near edge, far edge model that we talked about previously, and the speed, the enablement of SATCOMs and 5G networks, that's enabling the scale to grow horizontally, not necessarily vertically across geographies, which increases latency times, processing opportunities, and mission enablement by scaling out geographically. So we've seen that, you mentioned the satellites earlier, and with satellite communications, that's communications itself. But we're also seeing through our partnership with the Air Force, we've actually worked on a project called Edge One, where we're launching a satellite that's powered by our Kubernetes distribution K3s, and it's a very lightweight tactical distribution, but they're actually deploying on Raspberry Pi computers, the same ones you can go down and get at Micro Center. We wanted to show the commoditization of scale and how we can enter these new markets. So with the scaling out of data centers, I don't want to lose sight of the opportunities to scale out and use edge components as that near edge type of model, or the branch model in digital computing, to process, disseminate, and transfer data up into the larger repositories.
And so how does that affect where you store and where you house your data?
It depends on the architecture. So with the far edge type of model, you would think of a sensor or a single board computer in the field as just being a vacuum, right? So they're just sitting there and sucking up temporal data, climate data, possibly SIGINT, just collecting everything they can and just shoving it down the wire. At some point, it will be disseminated and processed. It's just there to be a vacuum. But that model is very complicated, especially in these high latency comms disadvantaged environments. So we're seeing a lot of customers starting to use a near edge type of model where they might have a sensor-based deployment, but then closer, whether it's at a fob or a data center closer to that sensor point, start to disseminate and process that data. So they might have a data center type of storage solution within that branch model, and then back at the cloud, if you will, or the upstream AWS or Azure data center, they might have a more long-lived type of storage model. So it's a question of meeting the mission where they are, rather than dictating the mission through highly prescriptive type of storage and computing models.
All right, good place to take a break. And there's a lot of follow-up we have, but I want to say that my guest today is Brandon Gulla. He's the Chief Technology Officer for Rancher Government Solutions. I'm your moderator, Tom Temin, on Federal Insights, sponsored by Rancher Government Solutions here on Federal News Network.